Here's an interesting problem. We have a discrete random variable table which lists if you were to seek x equal to 1, you would have a 1/4 chance. Maybe this is on a cube or something, and it probably would be a 4-sided tetrahedron cube, and one of the faces has a 1, one of them has a 3, and 2 of them would have a 2 on them. So your chances of getting a 1 would be 1/4, a 2 would be 1/2, a 3 would be 1/4. And I think that would work with the tetrahedron. If you had something like this, you put a 1 on the bottom, you put a 2 here, you put a 2 on the back here, and a 3 on the other back here, and you would have the situation you see here. Show that the probability generating function is given by. So you have g of t. I would take each of the probabilities in order, t, t squared, t cubed, and when you put those together, you'll have 1/4 t, 1/2 or 2/4 t squared, 1/4 t cubed. Factor out a t over 4, and you'll have 1 plus 2t plus t squared. And then that will be t plus 1 squared times t over 4. And that's what you wanted. Okay? Then for the next part, we're going to come up with this y distribution generator function and state the probability of generating a specific value y. And they're going to give the example of, let's say you wanted to get an 8. How would you figure that out? Well, you take your generator function, take each one of these, and multiply it together. So if each one of them, g of t was this t times 1 plus t squared to the 4th, you're just going to take those t to the 4th, t plus 1 squared to the 4th, over 4 to the 4th. And so that's what your y is going to be. Now, we struggled with this one a little bit, trying to figure out how to get a result of 8. And there should be a way to do that with this equation, but I could not figure it out. And if you find a better way, let me know. What I did is I thought, okay, let's look at all the ways that you could do this. One way is to get 2 1s and 2 3s. That would be 1 plus 1 plus 3 plus 3 will give you a total of 8. And ordering them from smallest to largest, there's a total of 6 different ways that this could be. The way you do that is there are 4 items factorial over repeated 1s over repeated 3s. So that's going to be 24 over 2, which is 6. So that's how I got the 6. Now each of those, the 1 and the 3, have a 1/4 probability of getting that. So to get that probability of getting a 1, 1, 3, 3, all those 6 different ways, will be 6 over 256. Another way you could get a total of 8 is to have 2 2s, a 1, and a 3. 4 plus 4 is 8. So there are 4 factorial ways. There's one way of getting a 1, one way of getting a 3. There's 2 ways of getting 2. So 24 over 2 is 12. So that's where I got the 12. Now the 2 has a probability of 1/2 from this problem. It has a 1/2. So since it's 1/2 squared, because we need two 2s, and then 1, 3, and 1, 1, 1/4 squared, will just be 12 times 1 over 64, which gives us 1 over 64. So we have these 2, and then there's one other way we could get that, and that is having all 2s. And getting all 2s, 2, 2, 2, 2, that's 1/2 each. 1/2 to the 4th is 1/16. So if you add these up, you're going to get 0.262, 2.273, 0.273, and that's the probability, excuse me, that you would get an 8. If you think of a different way, let me know. But